The aim of this presentation is to help designers use relevant sections of the Singapore Fire Code in their design process. This presentation is discussing the Code of Practice for fire precautions in buildings. The first part of the presentation will discuss the common timeline for a normal situation. Each stage is going to be discussed independently. Thereafter, I will differentiate between what is of designer's responsibility and what is of our scope. The last part will highlight potential defects that could occur in design and the valid solutions that can help overcoming such defects. It only takes 1 second to be engaged into the process, but it takes up to 6 weeks approximately for all stages to be completed. Researching is the second step in the timeline and takes around 3 days. It is considered a very critical step because layout vetting takes place in order to make sure that all fire code requirements were considered and applied carefully. After checking compliance of the layout with the fire code, it is submitted along with other important drawings to the Fire Safety and Shelter Department, FSSD, to obtain a Notice of Approval, NOA. However, each of the building plan submissions and the fire protection plan submission require 2 independent weeks. It will take around 4 weeks for this submission stage before the inspection takes place. The architectural inspection takes 1 day, but another day is required for the mechanical and electrical inspection. If all standards were met, a Fire Safety Certificate, FSC, will be awarded within a week, and the building shall be ready for occupancy. At this point, I will start the second part of the presentation, and will differentiate between designers' roles and ours. The designer is responsible for proposing the building layout and its corresponding plans, identifying its type of use, considering all the protection requirements including escape routes and distances between escape stairs, and proposing a detailed layout that presents the clear room functions and their occupancy loads. Most importantly, the designer should provide details about the responsible building for the submission. On the other hand, we are in charge for ensuring compliance of several critical aspects to make sure there are no defects. For example, we check compliance of hose reel coverage, distances between escape stairs, provision of fire escape routes with their proper signage, adequate coverage of fire extinguishers, relationship between occupancy load and escape doors, and corridors width, number of exits, and room-to-room issues such as fire, smoke, and heat transfer. Moreover, we are in charge for coordinating with an inspector to ensure compliance of drawings with the building. In this slide, I will provide an example of a non-compliance case that was solved successfully. The hose reel coverage requires 36 meters of length at most, since the hose itself can be pulled out to 30 meters and the water spray can reach up to 6 meters. Unfortunately, the existing location did not meet the requirements. As you can see, there is a large uncovered area highlighted on the right. We opted to change the location so protection of all rooms can be guaranteed. On the contrary, a compliance sample is shown in this floor plan. The extended dotted lines illustrate the 30 meters extension of hoses, and it shows that all spaces can be reached with one of those hose reels. The upcoming slide shall explain the compliance with travel distances. The maximum distance depends on the application of sprinklers in the interior spaces and the building use. However, no room should be located more than 30 meters away from any of the escape doors or stairs for a one-way escape layout, so exit routes should be located at a maximum of every 30 meters. For a two-way escape layout, the occupancy load will be divided and the evacuation will take less time, so the maximum distance between any 2 escape doors or stairs can be extended, but in all cases should not exceed 75 meters. However, the distance from any room to the splitting point between the 2 escape doors or stairs should not exceed 30 meters. The width of the escape door and the staircase tread width, they should not be less than 1 meter and 1.2 meter respectively. However, the corridor's width should be much wider and can reach 2 meters width like in hospitals. In this example, we can see that the maximum distance from the farthest rooms in this floor plan did not exceed 17 meters, which is optimum since it is around half the maximum allowed route length. This is an example of a larger floor plan that shows complex application of both the one-way and two-way escape systems. The allocation of an escape staircase in the centre of the floor plan was a smart solution because it reduced the distance between escape staircases on the far west and east. After covering the hose reel coverage, I will explain now the coverage of fire extinguishers. This FE type of fire extinguisher covers up to 15 metres in radius. The grey circles in this plan shows the diameter of each fire extinguisher. Although some parts have an overlap, which means that two fire extinguishers can protect it, other parts on the corners are unfortunately uncovered and unprotected. The solution for this problem was to add other fire extinguishers, even though 75% of their coverage area would not be beneficial since it goes beyond the walls of the interior space. This case shows full compliance to the Fire Safety Code. The total number of individuals who occupy an interior space, known as occupancy load, is critical since it affects the areas and dimensions of several aspects in the floor plan. The rule of thumb is to calculate the area per person according to the use of the interior space as shown in this table. The actual number of occupants can also be used to calculate it, but the greater value should be used for guaranteed safety. When the total occupant load exceeds 50 occupants, two exit access doors must be provided at a distance from each other not less than or equal to half the length of the maximum overall diagonal dimension of that specific interior space. In all cases, the doors must open in the direction of the evacuation flow. The number of occupants determines the width of the corridors, which range from 1.2 metres to 1.25 metres as presented in this table, and illustrated in the two figures in accordance with the number of occupants to be present in the rooms. This floor plan illustrates a compliance example in which the distance between two exit doors is 7 metres, which is half the length of the longest diagonal dimension of this boardroom. This slide illustrates an example of room-to-room issues in which the splitting point for the two-way exit route is obstructed with the door that opens only to the direction of room 2, although the occupant load is much higher in room 2 than room 1. Therefore, it was suggested to remove the door to allow evacuation to both staircases, hatched in red, from rooms 1 and 2. For the same reason, this door should be removed as well, because it opens just to one of the directions, which obstructs the flow of evacuation to the escape stairs. This door on the top right needs to be removed because it opens to an angle and hence obstructs the flow of occupants during evacuations in case of fire emergencies. To sum up, we discussed the interrelationship between occupant load and number of doors or staircases, direction of doors and corridors width. The same applied for the max travel distance and existence of sprinklers and if there is a splitting point in circulation. It is paramount to mention that a 1-hour fire-rated partition should be constructed in server rooms if the fire extinguisher was FM200 system-based, a waterless protection system. Finally, it is important to check length for hose reels, room-to-room issues, and requirements of fire extinguishers based on their types, exit widths, and guiding E-lights for evacuations.